guys, Mrs. Valdivia here. So we're going to go over the energy and specific heat lab. We're going to be doing this virtually. Okay, so the first thing we want to know is determining our unknown metal, and we have to write down what our unknown metal is. So if you guys take a look, put this up here. Your unknown number should be written in the bottom. So you've been assigned a number, either anywhere between like 1 through something. I don't know what. Last time I did this, I was number 4. So you're going to write your unknown. So in my case, my unknown is number 2. Right? And we're going to enter that into our box. All right. Next thing you know is we're going to be taking the mass of our known and the mass of our unknown. So the mass is equal to 20.562 grams. And by the looks of it, it looks like a metal. So description or observation. It's a metal and the color looks copper. Like a copper color. So I'm just kind of writing that down. I know it's not asking me, but it is proper procedure to kind of always write these different things down. Make that smaller so that I could write more. Here we go. Okay, so we're going to write our mass of 20.562. Okay, then it says tie the string around a metal and gently lower it into water in the beaker. So we're going to heat that beaker up or that water up, right? It says for 10 minutes. What you want to do is you want to actually boil the water to 100 degrees Celsius because you're trying to get the temperature of the metal to be 100 degrees Celsius or to be whatever temperature that water is going to be. In order to ensure that, you're going to have to heat it for 10 minutes, and that's going to ensure that that metal is that specific heat. All right. So while you're doing that, you're going to obtain, basically this is a styrofoam cup. And you're going to take a styrofoam cup and you're going to end up putting some water on it. However, before we put the water in it, we're just going to obtain what the styrofoam cup weighs. So we have a styrofoam cup. And the mass is 1.768 grams. And it says mass of the styrofoam cup and lid. So both of those together. We're going to add some water, and it says add enough water to the calorimeter so the metal will be completely submerged, between 50 to 100 milliliters. Measure and record the combined mass. So now we have styrofoam cup plus water, and that mass is 46.427 grams. Temperature of the boiling water bath. So remember, we had the metal boiling inside of water, right, for 10 minutes. We're going to record that temperature. So if we look at it, here's 100, here's 90, this is 95, 96, 97, 98, and it's almost 99 on mine. I'm not sure how to do a close-up. It says something about a close-up. All right, but I can do a close-up. So by the look of it, I have like 98, maybe 98.8. I don't know. So this is the temperature of water bath. Mine, I'm going to say, is 98.8 degrees. And remember, the temperature of the water bath is going to equal the temperature of the metal, of your unknown metal, right? Because your unknown metal was boiling in it for approximately 10 minutes. Okay. All right, now this one says initial temperature of the calorimeter water. So this is the temperature of the water bath. This is the hot water, right? And now we're going to take the temperature of the water inside the calorimeter, inside this cup. So the temperature of the water here, is, what is that? 24, no, 20, like 23.9, I would say. 23.9 degrees is the temperature of that water. And this is all in Celsius, by the way. All right. Now what we're going to do is we're going to mix them together. So we originally had styrofoam cup, and it had water inside of it, right? We poured approximately 45 grams of water, so approximately 45 milliliters of water. And it had a temperature of 23.9 degrees, okay? Then, inside this water, we added that hot piece of metal, okay? So we added the hot piece of metal, and heat radiates outward. So now the temperature of the water when we, actually the temperature of the metal was 98.8, right? And the new temperature of the water when we read it is 25, 26, 27, like 20, I'm going to say 26.9 degrees. So it went up on mine approximately 3 degrees. Right. So now we're going to take the mass of the calorimeter and water, and it says it's 4.648, and this is for trial number 2. So remember, this is everything we just did was for trial number 1. Now we're going to go to trial number 2, because we always want to do more than one trial when trying to obtain proper data, and we could get an average. Right. Write my, so this is trial 1. Trial 2. It's always nice if you print out the pre-lab papers, because those ones has like the charts really nicely set up already. So this one was water and styrofoam. This is going to be the mass, and we're going to need the temperature, right? And so the mass is 46.648 grams, and the temperature, we don't have that yet. So now we have the water of metal, right? The one where the metal is at. So we're going to do the temperature of that water. And that temperature of that water to me looks about 98.9 degrees. Okay. 98.9 degrees. And now we're taking the initial temperature of the styrofoam with the water. And that initial temperature of that is 21, 22, 23, about 24. Oh, actually 23, not 24. 23.8 degrees. Okay. Done that. Boom. We're going to mix them together. So just like this, we're going to now put the hot metal inside of the water. Not the water, just the metal. Okay? Just the metal. I've seen it done before where people just pour everything in there. You don't do that. You just want the metal inside of this water. So now when we pour it in there, the temperature change, so delta T, is equal to, well, actually, we don't know what it's equal to. We just know that it changed and it went to 25 point, I'm going to say 25.8. All right. Okay. And now that that's done, it says determine calories per gram in food sample. So this one's a little bit different. We're going to have to go back and do our math. So the math for, I don't know why my camera was all off. The math for our calorimetry, right? So this is everything we just did was the experiment of specific heat. Okay, now here it says determine calories per gram in food sample. Report your measurements to the correct number of significant figures. Whew. Obtain a food sample and measure and record its identity and mass. Enter the food being analyzed. Our food sample is Doritos chips. So, Doritos chips. How do I know? Because it says right here, it is Doritos chips. Okay. We're going to analyze it. We're going to go ahead and take the mass of this. Now what we're going to do with this one is a little bit different when we did the specific heat of the metal. We're actually going to burn the chip. And when you burn the chip, you can actually calculate the amount of energy being released by that chip, or actually any product that you can burn, you can calculate the energy. All right, so the way to calculate it is you're going to need the mass first. So put this on a different page. So this is now calculating energy of food. So we got the mass of the chip, and this is 1.924 grams. Okay. Mass of the can, so we're going to have a soda can here, and the mass of the soda can, it's an empty soda can, is 12.692. And inside that empty soda can, we're actually going to be adding water to it. So as you can see, we've now added water to this soda can and the mass increased. So now we have mass of can plus water, and that went to 117.811. All right, now obtain a ring stand. So we're going to set this up, and the setup is going to look similar to this. So you're going to have a ring stand, right? And in your ring stand, okay, here's the base of your ring stand, and this is called an O-ring, right? It's a very heavy metal O-ring. And when we assemble this, you're going to have your soda can here, and there's going to be a thermometer inside of that soda can. So you're going to have a thermometer inside of that soda can. And the reason you have a thermometer inside of the soda can is because there is water in here. And then you also want to cover up that soda can with some aluminum foil or something like that on top, like some sort of secure lid system. You want to prevent as much energy from escaping as possible to the surroundings. You want to keep as much energy inside of the system. Okay, so remember I said there's water in here, right? There's water. That's the water that's inside the can. And the temperature of that water, so the temperature, this is mass, so let's say the temperature of the H2O inside the can, and that is going to be approximately 20.9 degrees. And I got that from looking at the thermometer. Now we're going to finish setting this up. So here I'm going to have the Dorito, okay, and I'm going to place my Dorito on like a little something. So sometimes we use like a little corkscrew and something to hold it in. You know, usually you do Cheetos and you just stab it with like a paper clip or something. So this is a Dorito. I'm not quite sure how it works. Probably the same way, similar to. But what we're going to do is you're going to catch it on fire. So it's going to light up on fire, and the heat is going to radiate upwards onto the can. And what it's going to do is it's going to cause the water to heat up. So this is heat. And remember, it's radiating upwards. Now, since this is an open system, that means that heat is also going to radiate outward. And when you get heat in the can, that heat is also going to radiate outward because it's not a secured system. So you're going to have heat escaping to your surroundings. So we burn the chip, and our final temperature of the water is 20 degrees exactly. So temperature initial, temperature final of H2O of my water, we're saying is 20 degrees exactly. Oh, 20 degrees. What am I saying? 20, 21, 22, 23 degrees. 23 degrees. Okay, now I'm going to take the mass of my burnt tortilla chip. How much was left over was 0.350. This is the burnt burnt chip. And that was what was left over of that mass, right? Okay. So it says, use the following example of a nutrition label excuse me, to answer the questions below. Obtain a nutrition label for a food product and record the serving size and the total calories in one serving listed on the nutritional label. So the serving size in grams, according to this, is 55 grams. Okay. Total calories per serving from the label. So 230 calories. Okay. So for every 2/3 of a cup or every 55 grams, we get 230 calories. Record the grams of fat, protein, and carbs in one serving. Well, mass of fat is 8 grams. Mass of carbs, 37 carbs. And mass of protein, 3. You have reached the end of the data entry section of this assignment. We're going to now review and proceed. Awesome. Okay. Errors found. The data recorded is incorrect. Reevaluate your measurement for the initial temperature of calorimeter in trial 2. Oh, did I enter that wrong? Initial temperature of the calorimeter in trial 2. Okay, here's the calorimeter. Trial 2. Here it is. Okay, so 20, 21, 22, 23. I mean, that to me looks like 23.8, but it doesn't like it. So would it be 23? Hmm. Well, it's saved. It's not letting me. Oh, I have to fix. To do this from the beginning here. Okay, temperature boiling water. Just verifying 98.8. I still agree with that. 21, 22, 23, 23.9. Yes, I agree with that. 6, almost 27, 26.9. Yep. I'm cool. Okay, let's see. 98, 99, so 98.9. This is 21, 22, almost 23, so 23.8, maybe 23.7. And it's the only 7.2, and this is the temperature of making that change there. Oh, this is where I messed up. Okay. The final temperature, 20, no, 25, almost 26, 25.8. Yeah, still good. Ooh, man. This is getting some yawns out of me. Okay, hopefully I'm done almost soon with this. All right, done. So now we could do our calculations. All right, perfect. All right, so we're in the calculation section, and we want to identify the metal from the specific heat. So this is the first part of the lab. Okay. All our information is listed, and now it wants the mass of the water. So to obtain the mass of the water, we actually have to just do a little bit of subtraction. That's it. So we're going to take the mass of the calorimeter in water, which was 46.427. And I'm going to go ahead and subtract this mass from my mass of my calorimeter, which is 1.768. And I got 44.659. And that's the number of grams I'm going to get there. Okay, so now that I have that, I'm going to take the temperature change of the water. So the temperature change is final minus initial. So my final is 26.9. Minus the initial temperature of the water, which was right here, 23.9. And that is 3. Exactly 3. Now that I have that, I'm going to do the step 1 of our problem. So this is going to be on CP4 of the PDF for the lab. And it says calculating the specific heat of the metal. Now, before we can do that, we need to find the heat of the water, and that's what this is asking, heat gained by the water. So you're going to take the mass of the water times the temperature change and times the specific heat of the water. The specific heat of the water never changes, and it's going to be 4.18. Okay, and that is in joules per gram degree Celsius. Now, if you don't want to use 4.18 because you don't have joules, and you have calories, then you could use 1 calorie per gram degree Celsius. Now, the specific heat, it wants us to calculate it in calories, and then we're going to be turning it into joules. Okay, so just keep that in mind. Okay. All right, so okay, this one is showing you the conversion using joules per gram degree Celsius. All right, well, we'll just see what we get. Mass of the water, 44.659 times the change in temperature, which is just 3, okay? And I get 133.977. Now, let me just double check that unit. Calories per gram degree Celsius, okay? Our masses in grams, our temperatures in Celsius, and we're left with calories, which is the unit that we want. So I ended up with 133.977, so it's just going to be 134 calories. Heat lost by the metal. Now, the heat lost by the metal is equal to the heat gained by the water. Okay, so one more time. The heat lost by the metal is equal to the heat gained by the water. Now, because you're water is gaining the heat. In this case, it's giving it the negative sign. So remember, they're equal, so therefore in this case, 134. It's telling us to not include the negative sign, so I have not added any negatives. All right, temperature change of the metal in degrees Celsius. So the temperature change of the metal, we're going to do final, which is 26.9, right here, minus the initial temperature, which was 98.8. 71.9. The specific heat of the metal can now be calculated. So the specific heat of the metal is equal to the heat of the metal divided by the mass and divided by the temperature change as well. Okay, so all of this is how we're going to get the specific heat of the metal. So let's go ahead and do that. So we're going to take the heat of the metal, which we said is 134, and we're going to divide that by the mass of the metal, and the mass of the metal is 20.562, and we're going to divide that by the temperature change. So the temperature change is 71.9. Okay. And we're going to end up with the specific heat of our metal, and I got 0.0906. So I'm right, 0.6 to keep 3 significant figures. And that was in calories. And if I want to convert this using joules, I'm going to have to find my joule conversion. And the best way to do your joule conversion is basically just doing the whole thing again using joules as opposed to calories to do your calculation. You could also do a conversion. I don't know if it's here though. Yeah, I don't see that conversion. Okay, so let's just go ahead and do that from the beginning then, from right up here, and we're going to just multiply our 134 by 4.18, which is the calories, the specific heat, of water, 4.18. So we're here, we're doing this part of water when we ended up getting 134, but it was only multiplied by 1. Now we're multiplying it by 4.18, and that's going to give us our joules. And now we're going to take that number and divide it by the mass of the metal, which we said was 20.562, and divide it by the temperature change of the metal and the water, which was 71.9, and I get 0.3788. So 0.39. All right, so that's what I got for trial 1. I'm going to go ahead and do this now for trial number 2 as well, and then we're going to get an average. Okay, so the mass of the water. Okay, again, we're just going to take final mass minus the initial mass. So 0.648 minus 1.768. And we got 44.88. Temperature change of the water. So initial 23.7 minus the final, which was 25.8, 2.1. The heat gained by the water, so we're going to take the mass of 44.8 times the temperature change of 2.1, and I got 94.08. That means this is going to also be 94.08. The temperature change of the metal is going to be our final 25.8 minus the initial of 98.9. I get 73.1. And now I'm going to go ahead and calculate So to calculate this, I'm going to take my heat that I found, and I found my heat to be 94.08. I'm going to divide that heat by the mass of the metal, which was 20.562. And I'm going to divide it by the change in temperature. And the change in temperature was 73.1. And I got 0.06259, so 0.26. Okay, well, that's a bit of a difference. Okay, and then I'm going to also now do this using the 4.18 so that I could get joules. So I'm going to take my 94.08 times 4.18. So I'm taking this number, multiplying it by 4.18. And then I'm going to multiply it by, no, and that's it. So that's my 90, I got joules of 393. So I'm going to take my joules and I'm going to divide it by the mass of my metal, 20.562, and divide it by the change in temperature of 73.1. And I got 0. Now, hopefully I did all of these correct and I wasn't like messing up everywhere. It wants the average specific heat of the metal, so I'm going to take both of these numbers, so 0.262 plus 0.379, and I'm going to divide them by 2, and I got an average value of 0.3205. It wants me to identify the metal based on the average specific heat. So in order to identify the metal, I have to actually look at a chart. So we're trying to find a chart here, see if they give us one. All right, here's our chart. So we have specific heats in calories and specific heats in joules. So if we're looking for the specific heat in joules of 0.32, the closest thing to that is 0.39, which is going to be copper. Okay. Now, at the beginning when we wrote our description, we said it was metal and it had a copper-like color. So that also contributes, knowing the physical characteristics, contributes to identifying what our unknown is. So I'm going to choose copper. And now I'm done with that section. And the next section is going to be the calories per mass of food. So it's going to be our Dorito section. All right. So to calculate this, we're going to first start with this part where it says mass of the water. We want to know how much water is in our can. So we're going to take the 1/17 minus the 12.6 because this is going to be the mass of canning water minus the can. So we have 117.811 minus the can, which is 12.692. Okay. And that gives us the mass of our water, and that is 105.119. All right, now we're going to look for the temperature change of the water. Remember, temperature change is final minus initial. So the final is 23 minus the initial of 20.9, and I get 2.1. The heat gained by the water, so the number of calories gained by the water, that's going to be right here. So the heat gained by the water is the mass of the water times the temperature change times the specific heat of water. Okay, so the mass of the water is 105.119 times the temperature change of 2.1. And then we want the specific heat, and since this is going to be in calories, the specific heat of water in calories is 1. And so you just multiply it by 1 and you get 220.7499. So I'm just going to say something like that. All right. The heat gained by the water in kilocalories, so you're going to take that number and you're going to divide it by 1,000. And now I get 0.0 0.2207. Okay. 5. Okay. The heat lost by the food. So the amount of heat lost by the food. So it says this is also to convert the answer to kilocalories using 1 kilocalorie and 1,000 calories, which is what we did. We divided it by 1,000. This is also the heat lost by the food sample. So it also equals the heat loss. So that's 0.2075. And that is the kilocalories of the water, which is the calories lost by the food. Okay. Oh, actually, let's fix that. So it's 220.7 pounds. All right. So the mass of the burnt food. So where's the mass of our food? Mass of food samples here. And that's the final mass. And the initial mass is up here. So let's do the final of 0.350 minus 1.924. The mass of the burnt food is 1.574. Okay, and now we're going to calculate those calories. So you're going to take kilocalories divided by that mass of the food. So we're going to have the 0.22075 divided by the 1.574. So I took this number here and I divided it by this one. So the heat loss divided by the mass burned. And I got 0.140. So that was that. Okay, so we're going to be finishing this last part, the calculations for nutrition label analysis. And we want to find out the number of calories or kilocalories in fat, carbs, and proteins. And we're going to compare it to this value here, the 230 calories. In order to do that, we want to find out kilocalories. We have to get rid of the number of grams, right? Well, how many grams were in that serving? Let's scroll up to our data and see if we find it. We had, there we go, 55. So we have 55 grams in a serving of in one serving, right? So it's 55 grams in one serving. Okay. So now what we're going to do to find these out, we're going to take 8. Actually, we're going to take the 230 because that's the number of calories per 55 grams and divide that by 55. Okay, and we get 4.1818. So 4.182. Okay, I'm going to write that down, 4.182. And I'm going to take my 8 times 4.182, and I get 33.456. I'm going to do the same thing to the other ones, 37 times 4.182, and I get 154.734. And finally, the last one, 3 times 4.182, and I get 12.546. The total number, I'm just going to add them all together now. So 12.4 something plus 154 point something plus 33 point something. I'm actually writing the whole numbers down while we do this. I'm not just putting something. All right, so we get 200.736. Okay, we're noticing that these values are slightly different. Why are the values different? It says it's 230, but we got less. What happens when you burn the Doritos? What did we say? We have a lot of heat that tends to escape, right? So we have heat escaping from here. Heat is going up, burning your can, but we have heat escaping from the can. And we also have the heat that this metal rod absorbs. Remember, the metal rod is also absorbing heat. So a lot of heat is going to the surroundings, not just the system itself. So we can't actually calculate the true value, but as you can see, we're very close to that value. All right. I hope this really helped. Submit your notes and all that great stuff. And till the next one. Ciao.